Hello everyone, I present to you Bob. Now, here's a problem Bob's trying to figure out. Bob wants to choose between 3 water slides. He wants to get to the other side of the water slide as fast as possible. Now, what slide do you recommend for Bob to go to? Pause this video and try for yourself, or hear this little hint. It has to be an equilibrium of shortness and steepness. Answer in 3, 2, 1. The right answer is slide B. First of all, if you can't figure it out, don't be worried. Even Galileo got this type of question wrong, and he invented it. Let's understand what type of principle this question follows. This principle is a brachistochrone, and a brachistochrone is a curve between 2 points along which your body can move under gravity in a shorter time than for any other curve. If you take a closer look at the answer, you might realize that the curve looks like a curve of a circle, but not exactly. Now, most people might think that the answer is as simple as finding the shortest distance. So they might still pick slide A as the right answer because their intuition picks what's the shortest distance between the 3 slides, and that's the straight line. The answer seems reasonable, but it's wrong. Another thing people forget is that the fact that when an object falls, gravity accelerates it. Okay, sorry Bob. Now this is the biggest mistake people make when they're presented with the question. They just forget that the speed increases. Try it yourself. Ask your loved ones what happens when an object falls towards the earth. Will the ball speed increase or stay the same? They might stay constant if they answer the question immediately. If they do, ask them to think about it a little deeper, and they might change their answer. Now let's get back to the main question. If you make a line going directly down, then add a small curve, the speed and velocity increases as the ball goes down. Hence, it reaches the other side faster than compared to the shortest distance. Remember this. Now let's get back to the history of these types of questions. The question was first encountered by Galileo in the late 19th century. He thought the answer was a segment of a circle. So he took a circle, then he took a knife, sliced it as a segment, and removed the slide. And voila! He thought this was the right answer. This was thought to be the right answer until in 1697, a scientist known as Giordano Bernoulli, the person with his eyes going crazy, proposed a new solution that was far better. This was done by using a law known as Snell's law, but this law is rather complicated and very hard to explain. So let me simplify it for you. Picture this. You're a pilot. Good job. Now, your airplane is out of the field. Luckily, there's an airport nearby, but your airplane can only fly for the shortest distance before crashing. Now, the airplane flies faster if the wind is facing this way, but slower if the wind is facing that way. Now, to find the shortest distance, the ratio should be between the sides of these 2 angles, which should be equal to the ratio between the speeds across both winds. The resulting path will be the quickest distance. This is called Snell's law. Light also follows Snell's law to find the fastest route. So all Jonas did is constantly add glass bricks until the light bends into a complete curve. And voila, this is the brachistochrone curve. Jonas also found out that this was a cycloid. A cycloid is formed from a roulette, and a roulette is a path to a point on a rolling object. So how do you find a cycloid in this roulette? First you zoom in it, then when you flip it, voila! This is the brachistochrone curve in the slide. This curve is found in lots of places in the math world. There are also some other features of a cycloid which were rather interesting. Like when you have 3 cycloids aligned and roll a ball on whatever position you place the ball in, you'll reach the other side at the same time. How awesome is that? What we think is not always right. That's pretty much it. Good job.